So number 39, are we running? Hey, we are running. Good afternoon, everybody. Those of you who are at the game, you're definitely going to want to catch this on the router bus on the way home on your little phones. So number 39 was about electricity, which is cool. One of the hardest but most rewarding classes I ever had was electricity and magnetism. And so resistance is anytime an electric current is traveling through a conductor, there's resistance, yeah? Do you deal with that at all in physics or science? A little bit? Correct. But, they try to make conductors really good by doing what to them? They decrease the resistance. How? Super cool, actually. Uh, they super cool them to like almost absolute zero, and then apparently there's less resistance because there's less activity going on. Again, I am no expert there. I find that stuff fascinating, but I'm just definitely not an expert. But you don't have to be. They said the resistance R of R sub 1 and R sub 2 connected in parallel, and I do remember that parallel, you add them versus series. Pair P-A-R, 1L, 1R, 2Ls. Parallel. So 1 over R equals 1 over R sub 1 plus 1 over R sub 2. And then it says R is in ohms. Ohm. R1 and R2 are increasing at rates 1.5 and R at what rate? Okay. So R sub 1 equals 1 ohm per second. So that's a rate. And that's important, okay? That's really important. That's a rate. That's not resistance itself. And if we have a rate, what is this right here? If we're given a rate, something over something else, it's going to be what, Ian? It's like rise over run, yeah. So in other words, this is what? Slope. So this is the derivative of something, okay? This is the derivative of something. And in fact, it gets better because it's ohms per second. This is the derivative of resistance with respect to time. Think about it like that, okay? So that's nice. So this is going to help us later on, okay? And what was the other one? 1.5 R sub 2 equals 1.5 ohms per second. And that's a derivative also. So that's going to help us. Okay? Later on, just in our minds, we got to say, yeah, that's a derivative. Questions so far? Okay, so then, I got to remember how I did this. I did this yesterday, now I forgot. We know that those are increasing at those rates, and it says at what rate is R changing? Again, they're asking for a derivative. If it says at what rate is something changing, rate of change, I'm going to put in parentheses, rate of change implies derivative. I'm going to even say dr dt. Okay, so that's what we're going to be looking for down the road. But it's important in your mind to say, oh yeah, when R sub 1 equals 50 ohms and R sub 2 equals 75 ohms. And there's our related rates. Okay, so So far, so good? Any questions? Any worries? Okay. So we know that, let's take the derivative with respect to time of what they gave us before. I'm just going to clone this. Clone of all of this. Okay? So what is that going to look like? Well, first, again, to make it easier, let's give this a makeover. How should we rewrite instead of 1 over r? And some of you probably have it memorized by now, but if you don't, it's okay. Tucker, how would you write this without being fractions? I can invert them. R to the negative 1 equals r sub 1 to the negative 1 plus r sub 2 to the negative 1. You can. I think that's a good suggestion. Now, what are the derivatives going to look like for this then? Okay? Who haven't I picked on yet? Sophia, how is it back there? Quiet day. Okay, what's the derivative of this cat going to look like? Negative r to the negative 2 times dr dt. Okay, equals, you're doing great. Abby, how about the next one? Sorry? R sub 1 to the negative 2 dr sub 1 dt. You're right, it is the same thing. Uh, plus, last one, Marina. To the negative 2 dr sub 2 dt. Okay. Whoo, man. Now, let's, I think at this point we can go back to fractions. It might be easier. I think it will be easier. Some problems you won't need to. So this is negative 1 over what, Sam? 1 over r squared dr dt equals negative 1 over r sub 1 squared dr sub 1 dt minus 1 over r sub 2 squared dr sub 2 dt. Now here's a thought. You don't have to, but you can make your life easier right here by multiplying by something throughout. By multiplying by something throughout. What up? Even if I did, do you think I'd give them to you? Darn it. We can multiply by something special. No, you don't have to. I'm just saying this is totally, purely extra, but it makes things a little bit easier. What could we multiply by? Negative 1. Sure. Multiply by negative 1, and because they're all negative. So then we can say 1 over r squared dr dt equals 1 over r sub 1 squared dr sub 1 dt minus, or plus, sorry, 1 over r sub 2 squared dr sub 2 dt. Man, that is implicit differentiation squared. Okay, now we have then emission. Let's think about this. And I could have done that earlier. Yeah, we choose to not accept. Okay, recall. And I kind of did this in a wacky order. I could have done this earlier. 1 over, maybe I'll go back up. When r sub 1 equals 50 and r sub 2 equals 75, then we can say 1 over r equals 1 over 50 plus 1 over 75. And I could have done this at the beginning. There's no reason why. I don't know. Just afterthought. It's fine. Or you can do it now. It doesn't matter. Let's solve for r. What's that, Ian? 1 over r equals common denominator. $50 and $75, common denominator. Come on, Brett. 150. 3 over 150 plus 2 over 150. So now I'm at 1 over r equals 5 over 150. And r equals 30. Okay, so we can use that knowledge to our advantage. But we're not ready for that yet. One over 30 is the same as 5 over 150. 1 over 30 is the same as 5 over 150. No, just r. Good, thank you, Renee. And good point. We want to clarify that. Okay, so then, before we can plug that in, we got to solve for dr dt. Okay. Now solve for dr dt. This is kind of a crappy order. I apologize. I could have done that better. This part right here, I probably should have done it first. But that's fine. I'll just say may want to do first. It doesn't matter. It doesn't hurt anything, but it's just not as clean. Okay, so what did we end up with down here? That mess. Okay, so let's clone this and bring it down. So notice right here you've got a dr dt or some semblance of a dr dt. I got in a hurry. Will, you doing okay? Okay, now Will, help me out. Let's solve for dr dt, and then we can plug in everything we know. So help me. Oh, okay, I'm down for that. Multiply by r squared over 1, and multiply all of this times r squared over 1. We can just leave that. You could distribute, but I don't think you have to. My gut feeling is we don't have to. Okay? So now I have dr dt equals r squared times 1 over r sub 1 squared dr dt plus 1 over r sub 1, thank you, r sub 2 squared dr sub 2 dt. Cool, man, cool. Okay, so we have a bunch of stuff we can plug in now. We can say dr dt, the derivative of the resistance with respect to time, equals, what was r? 30 squared times 1 over, what was r sub 1? No, wasn't it 50? 50. 50 squared dr sub 1 dt plus 1 over, what was r sub 2? 75 squared dr sub 2 dt. Okay? And from there, oh, one more step then. dr dt equals 900 times 1 over 2500. What was dr dt? dr sub 1 dt. We know it. We love it. It's a rate. 1 plus 1 over 75 squared, I think was like 5625. I think I did that right. Times 3 halves. And I think you all can finish it from there. And you should get 3/5 of an ohm. Ohm, say ohm. Ohm, right, Kyle? I could see Kyle meditating. All right, I will call it a day. How many minutes did we do? 16 and a half. That's a bit. All right, so those of you who aren't here, enjoy this. And yeah, make it right and do calculus and be safe out there this weekend. Bye.